This presentation is all about distributions. Now, the most common example of a normal distribution that you'll see in textbooks is that of IQ. The mode, mean and median value of IQ is 100, and most people fall within the bell-shaped curve of a normal distribution, that's to say between 70 and 130 IQ points. If you remember what you learned in psychopathology about statistical infrequency as a definition of abnormality, what that means is anyone who falls outside of that curve, so below 70 or above 130, is seen as abnormal. So a normal distribution then is bell-shaped, it's symmetrical, the mean, median and mode all fall on the same central point, and the two tails never touch the horizontal axes. If you think about IQ and height and weight, which are both normally distributed, you can't have a zero value or an infinite value. As well as normal distributions, you can have skewed distributions. So you can have a negatively skewed distribution where the mean and the median are less than the mode, or you can have a positive distribution where the mean and the median are greater than the mode. The final type is a bimodal, which, as the name suggests, has two modal values. One way to try and remember what a positive distribution is through this concept of a happy whale. I know it's a bit silly, but it works. If you think of the mode as the whale's blowhole, the highest point on the whale is happy because it's swimming home. The zero on the graph, put H on one side of the zero, M and E on the other, and you've got home. So it's a happy whale going home. And you can see in this example that the mode is going to be less than the median and the mean. Conversely, a negative distribution is a sad whale. Sad because it's leaving home. It's going away from the zero on the graph. And in this case, the mode is greater than the median and the mean. So let's have a look at an example. A-level exams are designed so that grades are normally distributed. So the mean, median and mode is usually a C, and fewer candidates would achieve A star or U. They'd be at the ends of the distribution. So let's look at an example. If the distribution was negatively skewed, then that would mean that the modal grade would be a B. So more students were achieving higher grades. So what would the exam board need to do to get grade boundaries to ensure a normal distribution in this case? I'll give you 10 seconds to answer this. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And I'm sure you all answered A, they'd need to make them higher. And if the distribution was positively skewed, so this would mean that more students were achieving the lower grades and the modal grade might be a D, what would the exam board need to do in this case to grade boundaries? Again, I'll give you 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And I'm sure you all worked it out that it's got to be the opposite, so it's B, make them lower. For the next few slides, you're going to need some graph paper and a pen and a ruler. Once you get to each slide, just pause the presentation so that you can draw the graph. So what I'd like you to do is draw this graph. So the x-axis is the marks, and remember x goes across. The y-axis is the number of students. I also need you to calculate the mean, the median and the mode. Now I've done the mode for you. You'll see that the mode, the most common score was 100 because 50 of our fictional students got the score of 100. To work out the mean, again you're doing it on the x, the marks. So the middle value, there's 9 elements of data. So the middle value is 100 because we've got 4 each side. And to work out the mean, we simply add that column up, the x column, divide it by 9, and again we get 100. So you might have realised that this one's going to be the normal distribution because the mean, median and mode are in exactly the same place. So pause the video, draw this graph, and your title for it's going to be a normal distribution. Don't forget to label your x and y axes. Okay, so you've done the first graph. I'd like you to do the second one. Again, exactly the same thing. Work out the mean, the median and the mode. I've done the mode for you. You can see that 60 students got a score of 60, so the modal value for marks is 60. Again, work out the median exactly the same way we did before and the mean. And when you've drawn that graph, label it with what sort of distribution you think you've got. So pause the video now. The third graph then, exactly the same thing. You can see again, I've done the mode for you of 160. Work out the mean and the median and sketch it. So pause the video now. And the final graph, again I've worked the mode. This one you can see as a bimodal distribution because we've got two modes, 60 and 160. 40 students both scored that score. So again, do exactly the same thing, work out the mean and the median, sketch your graph and label it as a bimodal distribution. So pause the video now. Okay, so what you should have found, as we said, the normal distribution was the first graph. The mean, median and mode were all 100, all in the same place. The second graph was a positive skew because the mode of 60 was less than the mean and median of 100. The third graph was a negative skew because the mode was more than the mean and the median of 110. And the final one was a bimodal distribution. The mean and the median were 160 and we had two modes, 60 and 160. Let's have a look then at how you might be tested on this in an exam situation. This was off paper 3 from 2018. It's got a STEM, so remember there's AO2 marks, so you've got to apply your answer to the STEM. So using the data in table 2, explain how the distribution of scores in group A differs from the distribution of scores in group B. Now, students found this question a little bit tricky because if you look at group A, 22.4, 22.5 and 22 are not all exactly the same, but they are approximately equal to. Remember that little squiggly symbol? So that means that it is a normal distribution. If we look at group B, we've got the mode at 16 being less than the mean and the median. So remember, if it's less, it's our positive distribution, it's our happy whale going home. So a good answer to this, Group A's results who showed positive symptoms of schizophrenia, so that's our link to the STEM, showed a normal distribution of results for cognitive scores. This is because the mean, median and mode are approximately equal, so all fall in approximately the same place on the bell-shaped curve of the normal distribution. However, Group B's results who showed negative symptoms of schizophrenia showed a positively skewed distribution of results for cognitive scores. This is because the modal value of 16 is lower than the mean of 26 and the median of 22.5. So that answer would get you 4 out of 4. I hope you found this presentation useful and it's helped you to understand distributions. Thank you for listening.